Okay, we're on section 2.8, freely falling objects. So let's look at the picture, two pictures, Galileo Galilei and the Leaning Tower of Pisa. The Though it's believed to be an apocryphal story and it's legend, it's not real, but most people think of Galileo Galilei going up with two different masses of cannonballs to the top of the Leaning Tower of Pisa and dropping them to demonstrate that uh, uh, objects of different mass fall at the same rate. Uh, Whether he did that or not is unclear, but it doesn't really matter. He did do a lot of experiments with balls rolling down ramps and surmised that it really wasn't it, objects really wanted to keep on rolling if they were already rolling. And as he tilted up the ramps, he noticed that they fell at a faster and faster rate, and he was uh, discovered that objects fall at the same rate. Aristotle used to teach that objects tend to want to come to rest. Their natural state is to everything to come to a stop. Galileo uh, taught otherwise, that things in motion really want to continue in motion, and it was formalized by Newton later on, and we'll get that as we get to Newton's laws. I do have two videos at the end of this module. It says videos that are interesting videos related to chapter 2. It's an astronaut dropping a hammer and a feather back in 1979, I believe. The And it's also an experiment done with a feather and a bowling ball in a vacuum chamber. I recommend you. They're not. It's not assigned, but they're interesting. I recommend that you view them. Let me see if there was something else I was supposed to say about um, this chapter. Um, yeah, well, when we talk about freely falling objects, we're talking about a freely falling object is any object moving freely under the influence of gravity alone, regardless of its initial motion. Objects thrown upward or downward and those released from rest are all freely falling freely once they are released. That's right out of your textbook on page 42. So uh, we denote the magnitude free fall acceleration, also called the acceleration due to gravity. So in the previous equations, where we had a where we had the acceleration, we're going to have g now. So let me change the share. Oops, wrong one. Let's see. There it is. These are the equations of motion. These are very important for you to study and get used to. I don't know if this is in your way. I'll move it off to the side there. So where we have Vx final, so instead of A, we're going to use G, which is 9.8 meters per second squared. And if you want a quick calculation, you could just round that off to 10 meters per second squared. But in our calculations, we're going to use 9.8. So if we turn these constant acceleration equations into a vertical, everything is now y. It's now y. So the 213 becomes Vy final equals Vy initial plus GT. The A is now G. So the next one, the Vy average is equal to Vy initial plus Vy final over 2. I am going to post these notes, so you're welcome to copy them if you want, but you are going to get these notes. So now y final for 215, y final equals y initial plus 1/2 vy initial plus vy final times t. Now that's just v final equals v y final equals y initial plus the average velocity times t, and this 216 becomes y final equal y initial t plus 1/2 gt squared. And the last one is vy final squared equals vy initial squared plus 2g. I don't have to say a in the y direction, it's just g, 2g times y final minus y initial. And that is now your equations of motion in the vertical direction for free fall objects. And freely falling objects are those objects under the influence of gravitational force alone. So let's stop the share and go back to the PowerPoint. And let's look. Now here's some tricky questions. What happens to the acceleration of a ball after it is thrown upward into the air? Neglect air resistance. It increases, it decreases, increases then decreases, decreases then increases, and remains the same. Now, an important thing in this physics class is to always read the question. Make sure you understand what the question is asking. What happens to the acceleration of a ball after it is thrown upward into the air? It remains the same. It is 9.8 meters per second squared. 9.8 meters per second squared is the gravitational acceleration. It's always present. Whether you throw a ball up, whether the ball is on its upward swing or whether it's downward, the acceleration is always 9.8 meters per second. Now, what happens to the speed of a ball after it is thrown upward into the air? Neglecting air resistance. It increases, it decreases, it increases then decreases, decreases then increases, remains the same. Now, I'm going to say D. It decreases. In other words, the speed of the ball decreases until it comes to a stop, and then it increases going down. Let's see if I'm right. Yes, I'm right. So it decreases, the speed goes down, comes to a stop, and then picks up speed. As a matter of fact, the terminal speed will be this. Neglecting air resistance, the speed will be the same as its initial velocity going up. And we're going to stop there. I'll post both the PowerPoint notes and the little additional lecture notes that I had. Okay.